Bonjour, welcome to Wahsa Distance Education Center's radio Zoom classes. This is MBF3C, grade 11 college math, and I'm the teacher, Bronwyn Slade. If you'd like to participate live today, you can call the Wahsa studio at 465-7144 or 737-4017. You can listen on the radio at 91.9 FM and also on the television at Bell Express View channel 972. You are always welcome to join through the Zoom link, which is available from me, your teacher, and also your DEC. Our classes are scheduled from Monday through Thursday, 2 till 3 in the afternoon, and we are in our second week of our 9-week course. You need to know what work to submit for marking, as there's questions that you don't need to submit in your workbooks. The support questions, the ones with the pencil icon, are not to submit. They are practice problems. You do as many as you think you need to do. If you're understanding a concept, it is perfectly all right for you to skip questions. If you need more practice, let me know, and I'm happy to send you more practice. You know what your needs are the best. The answers are in the back of your book, so please check out your work. This way this way that you can understand what it is, where you're making mistakes, and you have a bit of an idea of how you might need to improve and where you might need some more practice. The key questions, the ones with the little key icon, are the ones to submit for marking. So please do all of these ones. Show all of your work, your steps, and your thinking. This way I can understand what it is that you understand, and I can give you part marks if you make an error along the way. It gives me more information about what it is that you're doing. So how do you actually submit your work for marking? Well, there's 3 methods. The first is to scan and send your work in electronically. So you can scan your completed work in using a device. If you have an Apple device, you can use the Notes app, and if you have an Android device, you can use the Google Drive app. Both these apps are free and generally do come with these devices. If you'd like to learn how to scan with these devices, I have tech tutorials on my YouTube channel where you can follow along and walk through how to do scanning. If you need to send pictures instead of scanning your work, that's fine. Scanning just makes the files smaller and a little bit easier to manage. Then you can send them to me through either email at studentwork@nnec.oen.ca and CC it to bronwyn.slate@nnec.oen.ca, or you can also send it to me through Facebook Messenger, where my name is B. Slate Wahsa. The second method is to drop your work off in Sioux Lookout. We have an outdoor mailbox at our location at 74 Front Street. We're the bright red building next to the post office, and we have a small white mailbox next to our side entrance. Just put your work in there at any time, and I'll get it back to you as soon as I can. The third method is to hand your work into your DEC. Your DEC can either send your work through the Express or fax it to 807-737-1732 or toll-free fax to 1-800-463-7852. Students are also welcome to send in their work by fax if you have access to a fax machine. If you'd like to connect with me through social media, both my Facebook and my YouTube channel are under the name B. Slate Wahsa. If you friend me on Facebook and subscribe to my YouTube channel, you'll get notifications every time I upload one of our radio Zoom classes. All of our radio Zoom classes are recorded, and I upload them shortly after airing. Also on my YouTube channel, I have short videos that explain common errors and confusing concepts, things that folks often struggle with. So that's a really good place to go and check out if you are struggling with something. It's a good place to start there. Math is a really visual subject, so I strongly encourage you to tap into the videos. If you can't join us live during Zoom and you can't access the YouTube videos, where everything's under a playlist called MBF3C. All of our lessons are, and any other support suggestions I have. If you're unable to do that and you'd like a copy of the videos, let me know and I'm happy to send you a copy so that you can still get the full experience. All right, if you have any questions or concerns, please reach out and contact me. My email address is bronwyn.slate@nnec.on.ca. My Facebook is bslate Wahsa. You can call me at 807-737-1488, extension 2209, or you can also call toll free at 1-800-667-3703. My office hours are Monday through Friday, 9 a.m. to 3 p.m. Though I teach the last hour of my day, so that's not a great time to try to get a hold of me. All right, today we're going to have our first Throwback Thursday lesson, focusing on lessons 1 through 4, because we've covered 1 through 4. So you might be asking, why are we reviewing already? Why are we going back over lessons 1 through 4? It's only been 2 weeks. But this is based on the idea that was generated by Hermann Ebbinghaus in 1885. And the idea that he researched that he had developed was that we forget things really, really fast. So he created this forgetting curve graph that shows that we retain information only for a very short period of time, and then we start to forget it. So by 1 day after learning something, we've already forgot almost 20% of that information, retaining only 80%. By day 2, now we've lost another 10%. We're at about 70% that we retain. If you continue this, by day 7, a week later, we are only at about 40% that we retain. So we've lost 60% of our understanding and what we remember about that topic. So with the continuation of this research is that if we revisit information, then we can retain it for longer. So not only do we retain it for longer, so we understand more of it because we revisited, so we filled our cup back up to 100%, but it takes longer for us to forget it. So we hold on to that information, we retain it for longer. So now instead of it taking only 1 day to forget 20%, because we've revisited once, and now it's going to take us 2 days to forget that 20%. And then we revisit it again. Now we've reviewed it 3 times, and it's going to take us 3 days to forget that 20%. And that continues, so that we remember more and we remember it for longer because we reviewed it. So that's the concept that I have in terms of us consistently going over our work, what we've already talked about, where we learned, so that when we come to the end of the course and you're getting ready for your final culminating project and possibly an exam, depending on what's happening, you're not totally like, well, what did we even do in lesson 1? I don't even remember that first unit at all, which has happened to me many a times, having to review the whole course right at the end and really feeling like I almost have to relearn stuff because it's been so long since I've thought about it. So we revisit the material that we've just learned, as well as all the material back to the beginning of the course, every week or every 2 weeks, depending on what's going on in our course, on Thursdays. This is my Throwback Thursday form so that we can remember what it is that we have already covered. So before we do that, of course, we're going to activate our brain with a little bit of mental math just to get ourselves warmed up. We know that I don't believe in mad math minutes, that they cause stress and anxiety in students and don't actually develop skills or confidence. So instead of focusing on that kind of strategy, we develop actual strategies that we can use in various situations and implement for however we need them with numbers that we're comfortable and confident with. So our question today is 16 plus 37, and we are going to use the idea of compensation. So this idea is that we're going to sort of share from one number to the other number. We're going to compensate. I often, as a kid, I would do this without realizing it was an actual strategy. but I would look at my numbers and I would say, well, if I stole from one of my numbers and I gave it to the other number, then that number would be friendlier and then I'd be able to add them together. So for my example, 16 plus 37, as always, there's multiple ways to do these. You can do it however makes the most sense for you. But for me, I might look at 37 and say, well, that's really close to 40. I just need 3 more. So if I add 3 more, because I know that 7 plus 3 is 10. So that means that 37 plus 3 is going to be 40. So if I can steal 3 from my 16 and I add it to my 37 to get 40, that means that I'm left with 13. So 13 plus 40 is 53. I can now add up using place value and it's fairly straightforward. So that means that 16 plus 37 is also 53 because I just moved part of it over first. And that's all that compensation is. And you can do this with any numbers. So getting to know what things make 10. So knowing that 2 plus 8 is 10, knowing that 1 plus 9 is 10, knowing that 6 plus 4 is 10. These facts help you be able to make your numbers friendly, and then you can steal from one to share with the other so that then it's friendlier numbers to add together. All right, so before we do some practice problems, we're going to look at the highlights of what we've learned already, just to review, as there's been lots packed in. So we want to remember what it is that we've covered already. So in lesson 1, this was our lesson on transformations. And so we remember that we looked at our general form of our quadratic equation, which is y equals a times x minus h quantity squared plus k. So a, we remember, is the opening of the parabola. So if it's greater than 0, if it's positive, then it opens up. And if it's less than 0, if it's negative, then the parabola opens down. Then we looked at h, which is the horizontal shift. And again, if h is greater than 0, if it's positive, then it shifts right. And if h is less than 0, the parabola shifts left. Remember, this is the one that's tricky. In your equation, the sign is going to look opposite than what it is that's actually happening. And then k, the vertical shift. And if k is greater than 0, then your parabola shifts up. And if k is less than 0, then your parabola shifts down. So those are if being able to manipulate those numbers means that we can create any parabola that exists. So that's what we did in lesson 1. In lesson 2, we looked at polynomials and factoring. So remember that we expand our polynomials using the distributive law. So we multiply each term inside the brackets by the term outside the brackets. And then if we were expanding and simplifying using binomials, we're using the distributive law. We used Algebra Tiles, the box method, and FOIL to remember how to do these, where we made sure that each part inside the brackets is being multiplied by each part outside of the brackets or inside the other bracket. And then we looked at factoring, where we first common factored if we could, make our lives easier. Then we found all the factor pairs of the constant term. So what are the numbers that multiply to be that last constant term? And we then identified which of the factor pairs adds up to be the coefficient of the middle term. So we were looking for 2 numbers that multiply to be that last number and add up to be the middle number. Then moving on to lesson 3, which was solving and graphing quadratic equations. Here, we remember that solving quadratic equations with factoring means that solving quadratic means finding the x values that make your y equal to 0. So finding your x-intercepts. And then we do this by factoring, meaning that we are finding the 2 factors that multiply to be our final product, because if either of those equals 0, then our whole thing equals 0, which helps us figure out what our x-intercepts are. We also looked at recognizing the zeros on our graph, where we saw that the x-intercepts or your zeros are where your parabola crosses your x-axis. And then in lesson 4, the exponent laws, we knew that we were always talking about when our powers had the same base. These rules only apply when our powers have the same base, otherwise it doesn't make sense. So our multiplying powers rule was that we add our exponents when we're multiplying bases that are the same. So x to the exponent a times x to the exponent b is equal to x to the exponent a plus b. The dividing powers rule is when we are dividing two powers that have the same base, then we are subtract the exponents. So b to the exponent b to the exponent x divided by b to the exponent y is equal to b to the exponent x minus y. And then when we have power to a power, the rule is that we multiply the exponents. So if we have t to the exponent n all to the exponent p is equal to t to the exponent n times p. And then we looked at the zero exponent rule, and we figured out that anything with an exponent of 0 equals 1, always. So doesn't matter what your number is, what your base is, it always is going to be equal to 1 when you have an exponent of 0. The negative exponent rule was our last one, and this one is tricky. It's a bit awkward, and so the idea is that a negative exponent equals the reciprocal of the base. So it's 1 over the base that we need to how we switch it. So this means that a to the exponent negative b is equal to 1 over a to the exponent b. Or if you have x over y all to the exponent negative z, then that is the same as y over x all to the exponent positive z. All right, and so that is what we've covered so far. Now what we're going to do is we're going to do a little bit of mixed practice. That we've done a quick review of everything that we've talked about so far. And we're going to do a bit of mixed practice, which the idea is that I have some questions from all of the lessons that we've done so far. But instead of me telling you, oh, this is from this lesson, and you know that we've practiced because we've just been learning about this one thing, they're all mixed up. So our part of what we need to do is figure out which type of question it is that we're doing and what tools do we need. All right, so number 1, you are creating a computer model of a skateboarder jumping off a ramp for a video game. The path of the skateboarders is modeled by the relation h equals negative 0.85 t squared plus 2, where h is the skateboarder's height above the ground in meters and t is the time in seconds. How far from the ground will the skateboarder be after 0.5 seconds? So this question is a solving quadratics question. We know this because we have a quadratic equation, h equals negative 0.85 t squared plus 2, and we're being asked to solve information about it. So here for part A, how far off the ground will the skateboarder be after 0.5 seconds? So that means that t is equal to 0.5. So because we know what t is, all we need to do is substitute t into our equation. So we have negative 0.85 times 0.5 squared plus 2. So we just need to put that into our calculator and calculate the that actual calculation. We don't need to do any manipulation. We just need to calculate. So negative 0.85 times 0.5 squared plus 2 is equal to 1.7875. So 1.9 meters. No, 1.8 meters, sorry. 1.8 meters. So the skateboarder will be 1.8 meters off the ground after half a second. There we go. We've answered that question. So part B, for how long will the skateboarder be in the air? So if we think about this, we have a skateboarder jumping. So we have our time versus our height. So we have a skateboarder jumping off of the ramp into the air and then into the ground. So we know that for how long they're going to be in the air, how we figure that out is that we need to figure out, well, when do they stop being in the air? When does this happen? And that happens when our height is equal to 0. So again, we're still going to use the same equation, negative 0.85 t squared plus 2. But now we're wondering what happens when, so we're looking for t, when is it going to be that they are at height 0? So we're going to put 0 in. So that means that we have negative 0.85 t squared plus 2. But this time, do we need to actually factor? We only have one t term. We only have one term that has a t variable in it. So that just means that we can just solve for t. So I'm going to rearrange. I'm going to add 0.85 t to both sides. Sorry, 85 t squared to both sides in order to make it positive. So that means I have 0.85 t squared equals 2. So then I'm going to divide both sides by 0.85 so that I isolate for t squared. Now I don't know what 2 divided by 0.85 is in my head, so I'm going to do that on my calculator. And I get 2.3529. It's a good idea to round to at least 4 decimal points when you still have more to do. So then I'm going to take the square root of both sides. So t is equal to the square root of 2.3529, which is equal to 1.53 seconds. Really, it equals to plus or minus 1.53 seconds. But does it make sense to have negative time? No, it does not make sense to have negative time. So that means that we are going to just say that the skateboarder is in the air for 1.53 seconds. There we go. All right, number 2. Consider the powers 64 to the exponent 2 and 16 to the exponent 3. Are these powers the same? Use the exponent rules to explain. So 64, so we could just evaluate them. We could just say, well, 64 squared is equal to 4,096, and 16 to the exponent 3 is equal to 4,096. So that would just be evaluating them, but that's not using the exponent rules to figure out they are the same. Yes, we know they're the same by evaluating them, but how can we prove that using the rules? So what I'm going to do is that we're going to try to make the base be the same so that we can compare the exponents and see if they're the same. So I know that 64 is equal to 2 to the exponent 6, I believe. Should check that out. I'm pretty sure. 2 to the exponent 6 is equal to 64. Yes. So that means that I can change my 64 to be 2 to the exponent 6. That's the same thing. And I want that still to be squared. So 64 to the exponent 2 is the same as 2 to the exponent 12. Okay. And then 16 to the exponent 3. Well, I know that 16 is 2. Well, I know that 16 is 4 squared. Okay. So that means that 16 to the exponent 3 is the same as 4 to the exponent 2 times 3 is 6. Well, I know that 4 is the same as 2 squared. So that means that 16 to the exponent 3 is equal to 2 to the exponent 2 times 6 is 12. And that means that we can see that they both are equal to the same thing. That yes, therefore, yes, the powers are the same. Sorry, this is an exponent law question. Tells us to use exponent rules, so that's kind of gives it away. Okay, number 3, graph the relation that, and then represent it with an equation in the form of y equals a times x minus h all squared plus k. So this is going to be a transformation question. Because we only know how to use this formula in the context of transformations. So I have a table of values. So I'm going to use my graph, and remember, I'm not amazing at graphing on my computer, so I apologize. So x equals -3, y equals 1. I'm going to put a dot there. And then it's good. Then -2, y equals 4. When x is -1, y equals 5. It doesn't, my pen, if I hold it too long, decides that it needs to erase my points, which is really not very helpful. When x is equal to 0, y is equal to 4. When x is equal to 1, y is equal to 1. When x is equal to -4, no, sorry, when x is equal to 2, y is equal to -4. My bad. Okay, so we can see that my parabola is going to look roughly like this. That's the beginning of my parabola. So, well, if we are thinking about what's going on here, A, we know is going to be negative because I'm opening down. And it doesn't look like I'm squished or that I'm narrower or wider. So my A is going to be -1. Then my H is equal to my horizontal shift. So have I moved my vertex? Is the easiest place to look. Have I moved my vertex away from 0, 0? Yes, I have. I've moved it to the left by 1. My vertex is now at -1, happens at -1. So that means that my H is equal to -1. Now my K, have I moved my parabola from 0, 0? Yes, I have. I've moved up. My vertex is now at 5. So K is equal to +5 because I moved up 5. So now I can figure out what my formula is. Y equals, instead of A, I'm writing -1. X stays the same. Instead of H, I'm writing negative. So I'm to X minus, then H, I'm writing -1. All squared plus K is 5. And then I'm just going to simplify this. So instead of writing -1, I'm just going to write negative and then X. And then because if I subtract -1, that's the same as adding 1, right? So that's why my sign is different. And then plus 5. And that is the equation for this parabola. Y equals -x plus 1 all squared plus 5. All right, number 4. Write an expression in simplified form for the area of this shape. And I've got a kind of funky L shape, and that has X's and numbers that tell me different parts of the shape. So I can tell that this is going to be an expanding polynomial question because I want to write an expression. So I'm going to want to multiply these together. So this is part of lesson 2. So there's a couple of different ways we could think about this in terms of how we're going to figure out the area. We could look at this L and we could think, well, we have this big rectangle, and then we're going to take away this small rectangle. That could be one way we could do it. Or we could think about it, I have this long rectangle here, and then this little small rectangle, and I'm going to add that to it. Either way is fine. Let's do, my gut is to do the subtracting way. That's the way that came to me first. So that means that for our big rectangle, so we have a big rectangle and then we have our little rectangle. So the area of our big rectangle is going to be our length times our width, but our length is going to be x plus 3 plus x plus 5 times our width, which is going to be 2x plus 3 plus 2x plus 1. So we need to recognize that we're talking about this whole side, and therefore we need to include both the parts. So then I'm going to simplify. So x plus 3 plus x plus 5 is 2x plus 8. And 2x plus 3 plus 2x plus 1 is 4x plus 4. So then if I simplify that, if I'm going to expand that, I could use my box method. So I have 2x plus 8 times 4x plus 4. So 4x plus 2x is 8x squared. 4x times, sorry, not 2 times plus 2x. 4x times 2x is 8x squared. 4x times 8 is 32x. 4 times 2x is 8x. And 4 times 8 is 32. So then the area of my big rectangle, if I write it all out, is 8x squared plus 40x, because 32x plus 8x is 40x, plus 32. So then my little rectangle is this space, this white space that I'm drawing blue lines in. And so the area of that is going to be x plus 3 times 2x plus 3. So that, again, if you wanted to maybe do FOIL, you do first times first. So 2x times x is 2x squared. Then outside 3, x times 3 is 3x. Then inside 3 times 2x is 6x. And then last 3 times 3 is 9. So if we simplify that, we have 2x squared plus 9x plus 9. So then the L shape area is equal to the big rectangle, take away the little rectangle. So my big rectangle is 8x squared plus 40x plus 32. Take away, and I want to take away the entire little rectangle. So that means I want to do negative. I'm going to take away and then I'm going to do a bracket. 2x squared plus 9x plus 9. So I have to apply that negative to each part inside of my brackets, right? Because I want to take away all three parts. So I'm going to have 8x squared, take away 2x squared, plus 40x, take away 9x, plus 32x, sorry, plus 32, take away 9. So 8x squared, take away 2x squared is 6x squared. 40x take away 9 is 31x. 32 take away 9 is 23. And that is a simplified expression for our area. So this one had a few steps to do it. And so it's important to show your information. My information isn't written the best way. I have not mastered writing on this screen, but make sure that you're keeping your information organized. All right, number 5, graph each relation by finding the x-intercepts. So remember, our x-intercepts are when our y is equal to 0. So here we have y equals x minus 5 times x plus 3. So that means for finding my x-intercepts is when y is equal to 0. So 0 is equal to x minus 5 times x plus 3. So that means that either x minus 5 equals 0 or x plus 3 equals 0. So x equals 5 and x equals -3 are our intercepts. So how I draw that, how I graph my relation is that I say, okay, my intercepts happen at x equals 5. So I drive a point on my x-axis at 5 and at -3. Those are my two intercepts. And now I'm going to, it's positive, right? So that it doesn't, my a value is positive. So I'm opening up. And so then I'm just going to roughly sketch what my parabola would look like, something like that. It's not perfect, but it gives us a rough idea. So B, we have y equals -3x squared minus 15x. So here I'm going to common factor out. Sorry, no, first I'm going to set it equal to 0 because that's when my intercepts happen, right? Is when y equals 0. So 0 equals -3x squared minus 15x. So that means if I'm going to common factor out -3x, because that's common in both, I end up with x plus 5. So that means that either -3x equals 0 or 5x plus 5 equals 0. So x equals 0 or x equals -5. So then again, I'm going to plot my points at 0 and -5. This time my a is negative, right? So that means I'm opening down. And I know that I'm going to be kind of symmetrical around my intercepts, right? It's going to, so it's going to look something roughly like that. All right, so let's do a few more factoring problems. Number 6, factor the following. Oh, sorry, that last one would have been a solving quadratic equations as well. So here we're factoring. So the question tells us that this is a factoring problem. So we have x squared minus 4. So this one is tricky, and I want to do an example because here we have x squared minus 4, and it doesn't look like we have an x term. So we want two numbers to multiply to be -4 and add up to be what? Well, if we don't have a middle term where we have an x, it's because we have 0 x's, right? We don't have a term. So that means that we are looking for two numbers that multiply to be -4 and add to be 0. So So we think about our factor pairs for -4. So we have 1, -4, -1, 4, and 2, and -2. Well, 2 and -2, if we add them together, that's going to give us 0. So that means that our pairs, our factoring, we have x minus 2 times x plus 2. And that's all we need to do. So these ones, when it looks like we don't have a trinomial, it's because we have 0 x's in the middle, and that makes it a little bit different. So here's another example. We have x squared minus 100. So again, here that's the same as x squared plus 0x minus 100. So we're looking for two numbers that multiply to be -100 and add up to be 0. So two numbers that multiply to be -100 are 10 and -10, and they add up to be 0. So we have x minus 10 times x plus 10. And there we go. C, we have x squared plus 25. So here, the last two, they were both minusing something, we're subtracting something. Here we're adding something. So let's see if we can figure it out for this one. So we still have plus 0 x's. This time we are looking for two numbers that multiply to be positive 25 and add up to be 0. So the factor pairs for 25 are 1 and 25, -1 and -25, 5 and 5, -5 and -5. Now, do any of these combinations add up to 0? 1 plus 25 equals 26. -1 plus -25 equals -26. 5 plus 5 equals 10. -5 plus -5 equals -10. So this is not factorable. We could solve it a different way. We don't have those skills right now. But if you are adding, and it looks like you don't, this kind of thing where you have 0 x terms and you're adding, you cannot factor it. It's not possible. And then let's look at another factoring. So here we have the trinomial again. We have x squared plus 14x plus 49. So we are looking for two numbers that multiply to be 49 and add to be 14. So that is going to be, well, 49, only the factoring pairs are 1 and 49, -1 and -49, 7 and 7, -7 and -7. Well, I want positive 14. That means that 7 plus 7 is going to give me positive 14. So I have x plus 7 times x plus 7. You might see this written as x plus 7 squared because I have the same thing twice. And so I can write it like that too. Both ways are fine. If you write it either way, I will totally accept it. They're both true and accurate. Okay. All right, number 7, simplify. So here we have a whole bunch of exponents. So these are going to be exponent laws. Forgotten an exponent. Okay, A, so we have 8 x to the 7th, y to the 3rd, z squared times 3 x squared, y to the 5th, z, all divided by -6 x, y to the 5th, z squared. So sometimes we get these questions just to make you practice manipulating your laws. They're not super fun, but they're not as bad necessarily. So what you're going to do is you're going to collect you're going to collect your numbers, because your numbers you can combine. So 8 times 3 divided by 6 are all your numbers. And then you're going to combine your variables. And I would always do it in the positive and then figure out at the end if I have negative exponents what to do with them. So I have x 7, then times x squared. So that means that I'm adding 2. And then minus x. So that means I have an invisible 1. So -1. My pen has decided to stop loving me. Come on. Now it's just freaking out. There we go. It thinks things. Tries to do things that are helpful and they're not helpful. Okay. So then now we're going to look at y. We have y to the third times y to the fifth. So 3 plus 5 divided by y to the fifth. So minus 5. And then we have z, and we're going to have z squared. So plus z, or times z to the 1, so plus 1 divided by z squared, so minus 2. So 8 times 3 is 24. So we're going to have 24 divided by 6. And then we have x. 7 plus 2 is 9, minus 1 is 8. Y, 3 plus 5 is 8, minus 5 is 3. Z, 2 plus 1 minus 2 is 1. And then we have 24 divided by -6 is going to be -4. And then we have x. We don't have any negative exponents, so we can just leave them as positive. Just leave them where they are. Z, we have an exponent of 1, so we just stop writing it. And there we go. That's how we do that kind of awkward question. Part B, we have x squared all to the exponent 4 times 3x to the exponent 5, all divided by 6, 10x to the exponent, 6x to the exponent 10. So again, we're going to do the same thing. We're going to bring our numbers to the front. So 3 and divided by 6 is at our front. And then we're going to simplify our exponents. So x squared all to the 4th means that we have x 2 times 4. Then times x to the 5th means that we are then adding 5. And then divided by x to the 10. So that means that we are subtracting 10. So 3 divided by 6 can be simplified to 1/2. And then x 2 times 4 is 8 plus 5 is 13 minus 10 is 3. So again, we end up with a positive exponent. So we could just say that that's x to the exponent 3 divided by 2. And there we go. All right, and one last set of questions. So number 8, express each as a single power. So basically the same thing, more exponent. I thought we needed some exponent law practice because they're tricky. So we have 8 to the exponent 2x times 8y divided by 8x all to the exponent z. So this has, we're going to take this in a few steps. We're going to leave the 8 to the 2x by itself first. And we're going to deal with what this part that's inside the brackets. So 8, we know that we need to apply this z to both the y and the x. So I'm going to do that first. Y 8. So that means I'm going to do yz on the top and 8xz on the bottom because we applied the z to both. And then we have 8 2x. We're timesing it by 8y to the exponent yz. So that means that we're 2x plus yz. And then we're dividing by 8 to the xz. So then we are subtracting 8xz, sorry. And that is all we can simplify because we don't have any like terms in our exponent. So that's all we can do. All right, then let's try this last one. 5 to the exponent 3b plus a divided by 5 to the exponent c minus 2a divided by c 5 to the exponent 3c minus b. Again, these are super awkward. They're just getting you to practice the problem solving and tracking of your information. This is not necessarily something you'll be using every day, I understand, but the point is to get you to organize your information. So they all are base 5. So we're going to have 5 to the exponent 3b plus a, and we are dividing. So that means we're subtracting our exponents. So minus, and then I have c minus 2a. I'm putting that in brackets so that I remember to apply that negative to both. And then I'm dividing again. So I have minus again, and then I have 3c minus b. So my exponent is going to be, so my base is 5 to the exponent, 3b plus a, and I'm just going to I'm going to apply these negatives to simplify my life so then I can organize them. So negative c plus 2a, and then minus 3c plus b. And now I'm going to rearrange them so that I'm going to collect all my a's together. So I have a plus 2a, so that's 3a. And then I'm going to look at my b's, and I have 3b plus 1b, so that's 4b. And then I have negative c minus 3c, so that's negative 4c. And there we go. Now I've done. That's all that I can do. Nothing else can be simplified. It's awkward, but with some practice, it's not too bad. All right, so now you have done you're prepared to be able to do all of the key questions in lessons 1 and through 4. So if you wanted to, you could submit them for marking. You could wait until you're finished lesson 5 and then submit whole of unit 1, but I'm totally fine with you submitting individual lessons. That's totally fine. You do whatever makes the most sense for you. Remember to do all of your questions, every single one, and show all of your work so I can help you if you're making mistakes, and then you can send me corrections and improve your mark. If you have any questions or you'd like to chat with me about anything, please reach out. You could give me a call at the office at 807-737-1488, extension 2209. You can call also toll free at 1-800-667-3703. Send me an email at bronwyn.slate, and that's spelled BRONWYN.SLATE@ednec.on.ca, or reach out to me at Facebook at bslate Wahsa. Remember, this lesson, as well as all of our previous lessons, are up on YouTube, where my channel is called bslate Wahsa. Everything is in a playlist called MBF3C. So check it out there. Then you can slow things down, pause them, come back to them, repeat them. It's a really, really great tool, because I know this stuff is a little mind-boggling. It's a little abstract. So check it out. My office hours are Monday through Friday, 9 a.m. to 3 p.m. except actually on Thursday when it's 10:15 to 4:15. So reach out to me if you want. I hope you have a lovely day and that this review was helpful for you. And we will connect again next week. Thanks so much. Mogwitch.